Okay, so here we want to solve for the integral x over the square root of x squared minus 7. Now we can see that it's x squared minus a squared. We know our a value will be the square root of 7. We want this to mirror this. So we want x to equal secant something, because then it'll become secant squared, and then square root of 7, so then it'll become 7 and we can factor it out. You'll see this more intuitively as we go along. So x equals the square root of 7 secant theta. So now dx, well, we'll keep the square root of 7 as a constant, and then the derivative of this is secant theta tan theta. So now we're going to input x into here, and then dx will be this. So let's make our substitutions. So we'll have the square root of 7 secant theta, and then dx will be the square root of 7 secant theta tan theta. And then this will all be over, well, the square root of, then square root of 7 secant theta squared minus 7. So now let's work it out and do some math. So these form 7, you have secant and secant, that's secant squared theta, and then tan theta. Now on the inside there, the square root of 7 squared is just 7, secant squared is just secant squared theta minus 7. Now within this, you could factor it out, right? You can factor out a 7 each time. So let's keep the 7 up here, tan theta, and then we'll say, well, the square root of 7, and we factor out a 7, we have secant squared theta minus 1. And then this just simply equals tan squared. So you can actually put tan squared into this. And then 7 secant squared theta tan theta over, well, the square root of 7 is just square root of 7. The square root of tan squared theta will just be tan theta. So this and this technically cancel. This and this technically cancel. And then you'll have a square root of 7 outside of here. And then we're going to say, well, square root 7. And then you're going to say, well, the square root of secant theta is just tan theta, right? And now, with our triangle that we made, you could actually look over here and see. So you can actually create a triangle and say, well, x over square root 7 equals secant theta. So what's secant theta? Well, if cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent. So then that's going to be x and square root 7. And then this side over here is going to be, well, this squared minus this squared, which is just 7, all square rooted. And then basically we want to ask ourselves, well, what is tangent? Well, tangent is just going to be opposite over hypotenuse. Sorry, opposite over adjacent. So then we'll just rewrite this as square root 7, then x squared minus 7 over square root 7. And then these two will cancel, and your final answer is x squared minus 7 plus c. And that's your answer. Now there's another way we could have done this. We could have done this by simple u-substitution. If we had just taken the bottom factor and say u equals x squared minus 7, the derivative would be 2x dx. We would put the 2 over here, so that would account for this. We would put du on top, and